Hi everyone, my name is Holly. I'm back with another video again. So this video I'm going to be looking at arthrokinematics. So that's basically looks at how joints move on their surfaces. So basically joint surface motion. And essentially we're going to be looking at the convex and concave rule. So convex, briefly to explain, is when the surface is rounded outwards, and concave is when the surface is rounded inwards. So there's two rules that you have to remember. So the first one, when convex is moving within a concave joint or on a concave joint, that's an opposite motion. And when concave is moving on a convex surface, that is considered a same motion. So right now we are going to go through a few examples. I'm going to kind of walk you through them and explain how this rule applies to those examples. So we will get started. I will show you them here. So the first example is this one right here. So that refers to how the tibia is moving along the femur. So in this sense, this is kind of a tricky topic that I once had difficulty learning. Took me a while to understand it. I'm hoping I can explain it well to all of you. So when the tibia is moving along the femur, basically means that you have to determine first which one is concave and which one is convex, and then you can figure out to think of how one is moving on the other, and then you can determine how the movements or the motions work. So basically, in this case, the femur is convex and the tibia is concave. So the way I think of this first example is that you have your femur is on the is basically your thigh, and then you've got your patella, and then you have your tibia. So essentially your tibia is the one that is the surface that is where your femur is kind of attached to or rubbing on against. So essentially, if I put this down for a minute, it's kind of like you have your femur and you have your tibia, and those are the ones that are joined together with the patella in the middle. But if we're not looking at the patella, you can see that it is the femur that is moving on top of the tibia. So the tibia is the one that has the open surface, or how I like to think of it, concave, as in a cave, because you can go inside a cave, therefore a cave is open. So in this case, it's the cave, the tibia, that is holding the femur inside of it. So I kind of think it like that. So in this case, the tibia is the concave and the femur is the convex. So we're going to look at another example here. So here I have the humerus, which is moving along the glenoid fossa. So the humerus is your arm, your upper arm here, and your glenoid fossa is where essentially your shoulder is. So it's where your humerus connects to your shoulder, essentially. So you think about it this way. So first, again, we have to determine which one is convex and which one is concave, and then we can determine the motions. So if you think about it, you've got if you see this picture here, you've got your humerus, and then this is the little kind of dividend where the glenoid fossa, it's called, where the shoulder joint would move within. It's kind of like a ball and socket joint. So essentially, in this case, the humerus is the convex and the glenoid fossa is the concave. Again, like I like to think of it, the concave is essentially a cave. It's open, so therefore that is the one that is holding the humerus inside it. So that becomes, so when you're talking about the humerus moving along the glenoid fossa, that means that the humerus is convex and the glenoid fossa is the concave. So that's our second example. So our third example, we're looking at, it's the first example, but it's flipped. So this is another thing to think about. So now we have the femur moving along the tibia. So in this case, again, we have to determine which one is concave and which one is convex. So in this case, the femur, we're thinking about it first, is going to be convex, like we said the first time. And the tibia is concave, again, because if you're thinking about it, your femur is sitting on top of your tibia. Your tibia is the one that has the surface that's open. I think of it again like a cave. And it's your femur that is moving on top of that when you move. So, essentially, this time, because it says the femur is moving along the tibia, we are going to say that it's convex on concave. So, now we're going to move on to the next example. So, now we're looking at the talus, which is your one of your bones in your ankle, and it's moving along the tibia. So again, we have to kind of think of the ankle here. So I have a picture of it here. So you can see that the tibia is the one, again, that has the opening, and the talus is the one that's kind of within that cave-like thing. So, or within the dividend, you could say. So the tibia is going to be the one that is concave, and the talus is convex. Again, the tibia is the one that has the surface that can hold it, open like a cave. So that's why the tibia is concave and the talus is convex. The talus is the one that's being held inside it. Okay, and we have our last example, which is the ulna moving along the humerus. So your ulna is your bone that is, like we explained in our clip before on the skeleton. Your ulna is your pinky side here, so it's going to be your bone along here, so along this way here, and then that's moving along your humerus, which again is your upper arm bone. So this one's a little bit more difficult to understand, but essentially your ulna is concave and your humerus is convex. So that basically means you have to think of this motion essentially when you're moving, you're flexing your arm, so you're moving it up and down, and you kind of have to think of how your humerus is this part and your ulna is this bone, so they're joined together by the elbow. So you have to think what is moving on what again. So in this case, you've got the ulna, which is moving on the humerus. So in that case, the ulna, again, is concave because it's rubbing against that open surface of the humerus, and the humerus becomes the convex. So those are 5 different examples that we went on through here. I hope you understand now the difference between concave and convex. It is a little tricky to understand in the beginning. However, what helped me remember the most is that you need to think of first what surface is moving on what joint motion is occurring. Is it either convex or concave? And then you need to just think about what surface is moving on what, put it together, and then you will be able to either create a table like this so that you're visually able to see it and look back at it and think about it, or you can also do a visual representation. You can put your hands together like this, and this will help you to figure out what is moving on what, and then you can determine which one is concave, which one is convex, and then you can determine which one is moving on what. So overall, I hope that helped you. Thank you so much again for watching. That'll be everything for this video. Bye for now.